Hello and welcome to Textbook Engineering Problem. Today we're working on Elementary Principles of Chemical Processes, 3rd edition. We'll be doing problem number 2.39. It says fit a line and a line through the origin to the following data using the method of least squares using the appendix A.1. And then they give us 3 data points. On a single plot, show both fitted lines and the data points. We'll go to the computer after this to be able to show the plots so you guys can see how to do that. Okay, 2.39. The points, they give us a table that looks like this. Okay, those are our data points, and then we'll use appendix A.1 to do this problem instead of normally. We could just do this on the computer like very quickly, but they want us to actually work through and do this problem by hand. So I guess I'll show that to you guys. Nobody ever does it this way anymore, but we'll show you the background math so you guys can see what the computer is actually doing. Well, first they ask for part A is to fit these points, or fit a line to these points that does not go through the origin. So it's going to look like this: y equals mx plus b, where m is the slope and b is the intercept. In part B, b equals 0. But right now, we're just going to have b equals some non-zero number. So they say that the slope, if the slope does not go through the origin, the slope equals sxy minus sx, sy over sxx minus sx squared. This is equation A1-4. Okay, and in order to define what s, x, y, and sx, all of these s values in this function, we use equations A.1-3. Okay, Sx equals 1 over n, summation I equals 1 to the n xi. So we're just adding all of the x's together. Okay, so this equals 1 over n equals 3 in our case because they only give us 3 data points. And then we're adding all of the x's together. So x is 0.3 plus 1.9 plus 3.2 equals, then we'll get our calculators out and do that, 1.8. Sy equals 1 over n summation I equals 1 to n of yi, which equals 1 over 3. Add all the y's together, 0.4 plus 2.1 plus 3.1. And this equals 1.867. Okay. Sxx equals 1 over n, summation I equals 1, n xi squared. That's the same thing, except you square all of these. Squared plus 1.9 squared plus 3.2 squared equals 4.647. S x y equals 1 over n xi times yi equals 1 over 3 times 0.3 times 0.4 plus 1.9 times 2.1 plus 3.1 times 3.2 and this equals 4.6767. So now that we've got all of our Sx values, we can plug in the value for the slope that we did before this equation. And the slope equals 0.936. And the intercept, this function, okay, 0.1818. Okay. So that is the equation for the line that does not go through the origin. And then it asked us to say, what is the equation for the line that does go through the origin? Well, we know that for part B, the line goes through the origin, so the intercept is at 0. So the slope needs to change slightly. And there's a different equation for the slope, because now our equation looks like this: y equals mx. And that's it, because b plus b is 0, so that goes to 0. So now we have a new equation for the slope, 1.006. Okay, and then it says on a single plot, plot both of them. Show both fitted lines and the data points. We will move over to the computer to do this part. Okay, we moved over to our computer. Let's put in our data points, x and y. Okay, let's put in our sx. So n, sx, sy, sxx, sxy, 3 equals n equals the sum of the x's divided by n. We'll make a x squared column here. And then xy column here. And this equals n. Okay, so then this is for our line, and this is for our line b equals 0. Okay, so m equals, and b equals times this. And the slope for this one is this. Okay, so this completes the section that they asked for, and now we can just plot the data. But something else I wanted to show you guys was how to do this exact same thing, just to do it in Excel and not do it with Appendix A like we just covered. And we'll see if the results that we got in Excel match what we got using Appendix A. Excel has a function called slope, which returns the slope if you know the y's and the x's. And this should return the same value as this line. So I'll move that up here. And yeah, those are equal. B should be the intercept. So intercept function, you just put in the known y's and the known x's, and sure enough, that is the same value. So Excel has functions that already do this. If we wanted to calculate the slope of the line through the origin, get the trend line off of the chart, so I'll put our data here. Data, get our x values and our y values. And then I'll make a trend line. And we'll say that it's linear. And then set intercept at 0. Okay, and then we can display the equation on the chart. So this is one way you can get a slope right there. This number should match this number, and it does. So that's another way Excel can do this trend line fitting for you. Another way you could do it is you could solve for it numerically. So you could set up a column of, you could set up a model like we've done in other problems. We could have our model here, and our model is y equals mx. So we could say this box will be our model slope. We'll say that it is this number. I guess we'll change it. We'll just say it's 1 for now, and then we'll see if it regresses, if it changes when we solve for it numerically. So this is our model column, and our model equals this slope times x. Okay? Then our model will have a certain error, and we'll sum and square the error. This array minus this array times this array minus this array. So this is the sum squared error. Okay, so we can solve this numerically. Our objective is to minimize the model error, and we're going to be changing the slope until our model error is at a minimum. So model error should be at a minimum, and we're going to be changing the slope. And the variable, our slope, is non-negative, so we can just leave this as checked, and then we'll solve it. Okay, and this number should match this number, and it does. So that's a numerical way to solve for this as well. Okay, so now we can plot both of these lines. So we've got one line on here already that Excel just automatically puts in, but if you wanted to plot the line yourself, we could say this is line, and this is line b equals 0, and this is our x values. So if we wanted to have our x values go from 0 to 3.5, so equals this plus We'll just give it a bunch of values up to 3.5. Okay, and then our line equals m times x plus b. This is our regression line. We need to make sure those don't change. Then b is equal to m times x. And intercept, or our slope doesn't change. We're forcing it to go through the origin. Okay, so now we'll plot our x values on our y values. And this is called line. And now we'll say line where b equals 0, x values, and y values. Okay. And we can change these so that they're a line. We just turn them into a black line. And say that it's black and it's dotted. Okay. And then this one, we'll say it's black as well, but it's dashed. Okay. So those are the two different lines that fit these 3 points. One is forced to go through the origin here, and the other one is not. Okay, so that's a plot of the graphs. And that is it for problem number 2.39. Hopefully that gives a good background for what Excel can do, and instead of doing it by hand, you can do things in Excel and they're equivalent. So I showed kind of both ways to do it. So nobody does this by hand anymore because it's much faster and easier to do these iterative or large groups of sums and things like that in a computer. So, but now you know the math that goes behind these calculations. All right, great. Thanks for joining me. If you have any questions or you need help on any problems from this book, just you can leave a comment down below and I will get back to you. I will try and solve that problem, help you out with that problem. Thanks for joining me. I hope to see you in the next video. Bye.